the next talk will be recycling, which was also one focus of the Innovate project. And I'm really happy to introduce Luis Hoffmann from the Fraunhofer IVV with this talk about recycling in construction industry. So, second. Here we go. Okay, Luis, the floor is yours. Luis, you are on mute. Your microphone is muted in your system.
Sorry for that.
Okay.
Yeah, thank you very much for the introduction, Daniel. I hope you can all hear me now.
Yes.
Perfect. So I'm a chemical engineer working for the Fraunhofer Institute in Freising, Germany, close to Munich. And as Daniel just mentioned, we were also involved in the Innovate project and mainly focusing on the recycling of those products. And I hope I can skip to the next slide now. Unfortunately, it doesn't work now. Okay, great, now it works. But since we're working on more than just one product from the building industry, my presentation will be a little broader, and we named it Recycling in the Construction Industry is the Future Circular. So that means that I will just have a look on a few more products coming from the recycling industry and how they can be processed or recycled. But before getting into that, I would like to give you an overview of what I want to talk about. I will introduce the Fraunhofer Society and our institute very briefly, so you know what we do and where we are, and then want to give you a short overview on recycling in the construction industry, what the challenge currently is, also what the current state of the art is, and then later what new challenges we are facing, and in the end we'll give a brief summary of the contents. As I just mentioned, I would like to start with the introduction of the Fraunhofer Society. Hopefully some of you have already heard about us. We are a society focused on the applied research directly with private companies or the public sector. Have about 70 institutes all across Germany and also some international offices and institutes, but most of our institutes are in Germany and have approximately 25,000 people working for the company. And our institute is, as I already mentioned, located close to Munich in the south of Germany, in the village Freising. And we have in total 5 business fields in our institute. So it is coming from actually the food sector, because we're related to the Technical University of Munich, where there is also research on food. And from research on food, there was packaging as a closed field that then was established within the institute. With packaging came processing machinery that's also required for the processing of this food packaging. And in parallel to that, product performance is one of our business fields where we evaluate for example, smell, taste, or whatever of new products, also not only of food, but also of packaging materials and of recycled materials, which is the business unit I'm working with. We are mainly focused on recycling of polymer materials. We were coming from the packaging and packaging materials, but expanded to more polymer materials, also coming from the construction industry. And this is what I want to talk about next. On the right, you see a graph which shows the waste volumes in Germany in 2018 and the sources where those materials come from. You can see that the construction industry or demolition produces, at least per mass, not per volume, by far the most waste in Germany, and this is also true for many other Western countries. And this shows that there is a large potential in the field of recycling for materials coming from the construction industry. And as for all materials here, the main challenge that we have is to separate one specific kind of material at a very high purity in order to be able to reuse it in another applications. But since at least per mass, the materials used in the construction industry, the prices are rather low. Very complex recycling processes cannot be established just because processing costs have to be taken into account. And if the processing costs are higher compared to the value of the product, it can be challenging. But nonetheless, already many materials used in the construction industry are currently being recycled, which I will get to later. But especially with polymers used in the industry and complex multi-materials, we face new challenges that have to be solved in terms of recycling. So to start off, I would like to give you just a short overview over the state of the art of materials that are currently being recycled. As you probably all know, steel is used in a circular manner. It's used very commonly and broadly in the construction industry, can be reused in blast furnaces to produce new steel. So we have a closed loop and the recycling works quite well. Another example are windows. I used this as a kind of special material just because here we have a polymer or polymeric material that is already reused in the construction industry. Glass, as you probably all know, can be recycled quite well, but also the plastic frames of windows that are mainly used can currently be recycled, and there's also an industry dealing with those materials. So another material or another example where recycling works really well. And the third example that I want to give is concrete, probably one of the most used materials in the construction industry, that it can also be reused, for example, for road constructions. But as I already mentioned, those are just some of many materials that can be recycled within the industry. And I try to find good numbers on how much of the total volume of waste coming from the recycling or from the construction industry is going back into new applications. And to be honest, it was quite difficult, but the best numbers I could find were indicating that about a third of the materials can currently go back into new applications, but that on the other side means that there is still 70% that we have to have a look at and that we possibly should recycle. And we at our institute are currently dealing with 3 of those materials that are difficult to recycle. And on the one hand, we have EPS insulation, polystyrene insulation that's very commonly used for the insulation of housing. There, the problem that we're facing is that there are flame retardants within the material that make recycling challenging. The second material we're dealing with is flooring, PVC flooring, which is also challenging for recycling. And the third, of course, in scope of the Innovate project, were vacuum insulation panels. And the approach that we have for all those materials, because they contain polymers, is to selectively dissolve one of the polymers at a time with the so-called Creosote process that was developed at our institute. So what we do is we take a waste fraction that contains polymers. We use one of our solvents, which at first can be reused within the process. So we don't really produce a new waste as solvent, but can always reuse the solvent, and also use solvents with low toxicity, so that are safe to use. And with this solvent, we selectively dissolve one of the polymers in the product or in the waste stream. then filter out everything that is not dissolved, which can be any solid material, and then recover the polymer from the solvent or from the solution with a precipitation process or a drying process to recover our pure new polymer. And as you can see here, the solvent is going back to the solution, and all impurities or contaminants can be removed within the process. But since this whole webinar is focused on vacuum insulation panels, I would like to start with those. And yeah, as we've already heard, they're a highly effective insulation material for buildings at very low thicknesses. But as Kenny already showed, the structure of those materials compared to other insulation materials is quite complex. So we have the core material, we have a fleece around them, possibly cardboard, aluminum layers, then we have the envelope, and also on top of the envelope have layers that protect the panel itself, and later maybe even a third layer being plaster just for visual appearance on the building. And our part, the Fraunhofer IVV's part in the project, was to design a recycling process for those panels, for those materials, to then also show that the recycling process is not only possible theoretically, but can be actually established by doing trials with the technologies we selected, and then also to evaluate the products that we receive from the process. And it became clear during the project that the panels can, or most of the materials that are used in the panels can be recycled quite well. So Kenny already mentioned the core material is the largest fraction of those materials, and it was what was possible quite easily to recover that material from a shredded waste fraction of those panels. But later downstream, it was also possible to separate all the polymers used in the envelope, which is usually PE and PET, using our solvent-based approach, and also to recover other materials used like the fleece or cardboard in mechanical processes like wind sifting. So overall, it looks like the recycling of those panels is feasible, and yeah, we shouldn't run into any severe problems with using those panels. But since we're also dealing with other materials at our institute, I would like to introduce also a second project that we're working on called circular flooring, where we're dealing with PVC flooring. The challenge with PVC flooring is that in the past, often plasticizers have been used in those floorings that are hazardous, for example, DEHP, and which can no longer be reused for new PVC materials going to the market. So those plasticizers have to be removed from the floor and before the material can go to another application. And with our process, we are able to remove more than 99% of those plasticizers. And in the project Circular Flooring, we're currently developing a plant or scaling up the process to a technology readiness level of 5 to 6 to show that this is also possible in a technical scale, and are funded for that by the European Commission and the Horizon 2020 program. And the third material I would like to talk about is EPS insulation. Here, the project that we're mainly working on with EPS insulation is polystyrene loop. The challenge with EPS insulation is that the material contains flame retardants, most of the time HBCD, with the same problem as the plasticizers before for flooring, Those were used in the past, but no longer can be used according to REACH regulations. And next to that, we often have impurities in the material like plaster or any other construction material. And we have to remove those from the polymer itself. And with our solvent-based approach, we were able to recover HBCD to a level of less than 100 parts per million, which is a threshold that is compliant with REACH regulations, and will presumably start up a pilot plant mid-2021 in the Netherlands, where we show that this recycling can also be done in large technical scale and commercially. So summarizing, I think it became clear that recycling processes in the construction industry are still needed, because there is still a large fraction of materials that currently cannot or are not recycled. But there is a large potential, just because the volume of that waste is severe. And the recycling industry can not only be a source of waste, but also be a destination for recycled material. That is especially true for inorganic materials like concrete or also steel. And we hope that in the future also polymeric materials can go back into the construction industry. But according to we think that for that we need new processes to increase the amount of recycled materials, and then to hopefully further and further close the loop in construction industry.
Okay, thank you, Luis, for this talk. I see a lot of room for collaboration there with your institute. Maybe we can have one question, because we're a little behind schedule. Caroline, do you have something?
Yes, I would also like to give a quick remark here, because this came up twice during the questions now. All the questions you asked will be answered. If it's not answered directly after each talk, it will either be answered in the Q&A sessions, or later on you will get notes and written answers to your questions. So don't worry, each of you will get an answer. So just one quick question for Luis would be, do you have a number of how much PVC is actually reused in reality, apart from the downcycling approach?
It really depends on the source of material. So as I mentioned earlier, windows are recycled quite well. Flooring so far, or to my knowledge, is barely recycled. So I would have to look up numbers for window frames, to be honest. For other materials, I think most of the material is going to downcycling or to incineration, or for example, to just waste collection systems.
Okay, thank you very much, Luis.